Okay, another way we can solve a problem is sometimes you can't go in the front door. You can't prove that something is always true, because you can't do every example or test every situation. But what you can do is show that something is not true by using a counterexample. So let's look at order of operations. In math, order of operations is extremely important, and your calculator knows order of operations, so hopefully you will as well. All right, so we probably heard this as PEMDAS, which is parentheses, exponents, multiply and divide, add and subtract. Okay. Now, if we're looking at this in terms of math, we know that parentheses are actually grouping symbols. They can be parentheses or brackets or braces or the absolute value sign or above and below a fraction bar. Now, this is the one that probably confuses some of us. If I have 5 plus 7 divided by 3 plus 2, then what that means is I have to do this and then this. So it would be the equivalent of 5 plus 7 divided by 3 plus 2. And of course you would do what is in the parentheses first. Exponents, of course, you would want to simplify all exponents. If you have something to the nth power, that means a times itself n times. Okay. And so for an example of that, you might want to say like 3 to the 4th is 3 times 3 times 3 times 3, which is 81. Okay. Adding and subtracting, multiplying and dividing goes from left to right. This is really important. You don't do all the multiplication and then go back and do the division. They have the same weight. You just have to do them from left to right. And same thing with adding and subtracting. You go from left to right. Now the cool thing is, again, that your calculator knows these operations. Okay. So let's consider this expression, x plus y to the second and x to the second plus y to the second. So let's look at these individually and see what are we going to do first. Okay, well, if I look at this, if I have x plus y to the second, what I do first is what's inside the parentheses. I have to do that. And then secondly will be the exponent. Now, whereas here, these are separate and they're separated by addition, so I'm going to have to do the exponents first, and then I'm going to have to do the addition, which again, the addition here is inside the parentheses. Okay. These two expressions are not the same. Okay. But what we want to do is be able to show that, and we can do that by choosing any two numbers for x and y. Okay, so let's let, I don't know, x equal 5 and y equal 3. Okay, so if I have 5 plus 3 to the second and I do the addition first, then that is going to give me 8 to the second, which is 8 times 8, which gives me 64. If I do not have the parentheses, I'm going to have 5 to the third plus 3 to the third. I'm sorry, to the second, excuse me. I didn't think that was right. Well, 5 to the second is 5 times 5, which is 25. 3 to the second is 9, and that gives me 34. So they simplify to the same number? No. Did you prove that it's false? Yes. And again, there's no way you could try every combination of numbers to support that it's true. So what you would want to do is try to find a counterexample. Okay. All right, so now we've got some practice problems. So either in your group or you were sent home with these problems. You had a 3-course dinner last night, an appetizer, an entree, and a dessert. The appetizer choices were soup or guacamole, the entree were chicken, fish, or eggplant, and the dessert was meringue pie or ice cream. Find the total number of dinner combinations using the multiplication principle. Okay, well, let's see what our choices are. We are going to have choices for the appetizer. Okay. We are going to have choices for the entree. And we are going to have choices for dessert. I think. And what am I going to do with these? I am going to multiply those together. And this will give her our total combos. Okay, so let's see, for my appetizer, soup or guacamole, so there were 2 choices there. Entree, chicken, fish, or eggplant, there were 3 choices there. And dessert, meringue, pie, or ice cream, so there were 3 choices there. So if I multiply those all together, 2 times 3 is 6 times 3 is 18 total combinations. But let's do a tree diagram and see if this actually works out. Okay, so I don't know. I think it's better to do it horizontal with the space provided here. So we've got the appetizer, and we have 2 choices for that. We either have soup or guacamole. Then I have the entree. And there are 3 choices for entree, and I'm going to spread these out a bunch. Okay, so for my entree, I can either have chicken, fish, or eggplant. Chicken, fish, or eggplant. Then I have my dessert. And for each of these, I have 3 options. It's getting a little crowded in here. These are hard to draw. Okay, so for dessert, I can either have meringue, pie, or ice cream. Meringue, pie, or ice cream. Meringue, pie, or ice cream. Or ice cream. Okay, so now it asks to make a list. So let's see, I'm going to do soup, chicken, meringue, soup, chicken, pie, soup, chicken, ice cream, soup, fish, meringue, whoops, soup, fish, pie, or soup, fish, ice cream. Then I have soup, eggplant, meringue, soup, eggplant, pie, soup, eggplant, ice cream. So those are all the combinations with the soup as an appetizer. Now all of these are going to be the same, except instead of S, I'm going to have G in there. So this is going to be guac, chicken, meringue, guac, chicken pie, or guac, chicken ice cream, guac, fish meringue, guac fish pie, guac fish ice cream, and guacamole eggplant meringue, guacamole eggplant pie, guacamole eggplant ice cream. So let's count these up. 3, 6, 9, 12, 15, 18 choices. Okay. All right. Now, I am addicted to Sonic. I go there all the time. And it advertises that it's the ultimate drink stop. What does that mean? Well, this is not actual, but we're going to, because it says it has over 1 million drinks, and there's actually some information. I got mine from the Wall Street Journal about whether or not that was truth in advertising, and it is. But you'll be able to see how the combinations add up. Okay, so they advertise that it's your ultimate drink stop. Suppose they have 8 basic drinks: Coke, Ocean Water, High C, Sprite, whatever it is. And then once you've gotten one of those 6 basic drinks, there are 16 possible add-ins, your cranberry, your lime, your coconut. How many drink possibilities are there? Okay. Well, let's start out with the basic drink. There are 8 possibilities for the basic drink. Okay, so now we want to think about the add-ins. For each add-in, there are 2 possibilities, either yes or no. So if you want cranberry, so this would be add-in number 1. It's either yes or no. So there are 2 possibilities here. Same thing for add-in number 2. If that's lime, yes or no. Add-in number 3, yes or no. And this would continue on until you get to add-in number 16. Who knows what it would be by then. Okay. So for the multiplication principle, you are going to have the number of combinations you would have 8 for the basic drink and 2 for each of the 16 add-ins. So it would be 8 and 2 times 2 times 2, 16 times, and what you end up with is 524,288 different drink combinations. Okay. All right, I just thought that was kind of a fun problem. All righty. Carlos made 66 phone calls to gather support for a political candidate. The number of senior citizens he contacted was 3 times the number of young adults. The number of middle-aged adults was 1/2 the number of senior citizens. How many senior citizens did he contact? Okay, so what do you want to know? The number of senior citizens, or I'll just call them seniors, contacted. Okay. But we have 3 different things here. We have senior citizens, we have young adults, and we have middle-aged adults. Okay. All right, so what do we know here? We know the number of middle-aged adults was 1/2 of the number of seniors. So to find the middle-aged, we need to know the number of seniors. And it says the number of seniors is 3 times the young adults. So to find the seniors, we need to find the young adults. Okay. So we need young adults to find the seniors. We need to know seniors to find the middle-aged. So what do we know nothing about? We know nothing about the young adults. So that is going to be our guess. Okay, well now we can find the number of seniors. It's 3 times the young adults. And so this, I'm sorry, this is going to be seniors. And let's see, the middle-aged adults, this is going to be 1/2 the number of seniors, and that's going to give us the middle-aged. And we know he made 66 phone calls. So the young adults plus the seniors plus the middle-aged has to equal 66. Okay, we're just going to guess. I'm going to start with something easy. I'm going to do 10. That means the young adults, or the seniors, is going to be 3 times the young adults, which is going to be 30. And then the middle age is going to be 1/2 the number of seniors, which is 15. So we have 10 plus 30 plus 15, which gives us 55. And this is going to be too low. Now, since I'm cutting something in half, I'm only going to use even numbers. So let's try, I don't know, I'm quite a bit short, so let's try 14. Okay. 3 times 14 is going to give us 42. And then 1/2 of the number of seniors is going to give us 21. So I have 14 plus 42 plus 21. That gives me 56, 77. So that is too high. So let's go in the middle. Let's do 12. So 3 times 12 is going to be 36. 1/2 of 36 is equal to 18. And if I have 12 plus 36 plus 18, that gives me 66. And I got it just right. Okay, use a counter example to show that A times B plus C and A times B plus C is a false statement. Okay, let's let A equal 2, B equal 5, and C equal 8. Okay. If I have A times B plus C, then that gives me 2 times 5 plus 8. I have to do what's inside the parentheses first, so that's 2 times 13, which gives me 26. If I have A times B plus C, then that gives me 2 times 5 plus 8, which gives me 10 plus 8, which gives me 18. And you might not always find a counterexample on your first shot. Okay, let's do 2 more problem solving. Nadia takes a ribbon that is 48 inches long and cuts it into 2 pieces. One piece is 3 times as long as the other. How long is each piece? Okay. Let's just write these into 2 different, we know we're dealing with 2 pieces, so I'm going to call these piece 1 and piece 2. And I know that the total is 48. Okay, it's 48 inches long. Okay. Now it doesn't tell us which one is piece 1 and piece 2, so it says that one piece is 3 times as long as the other. So let's say that piece 2 is 3 times piece 1. They didn't give me anything about piece 1. Okay, so that's where I'm going to start my guess. And I'm not going to draw a table. You don't have to be quite as formal in that. So I'm going to have piece 1, which is my guess. I'm going to have piece 2, where I'm going to calculate 3 times piece 1. And then I'm going to have my total. Okay. I like to start with nice even numbers, so let's start with 10. This is going to be 3 times 10, which is 30. And 10 plus 30 equals 40, which is too low. Okay. Let's do 15. 3 times 15 is 45. 15 plus 45 is 60, which is too high. 48 is closer to 40 than it is 60, so if I'm going halfway in between here, I'm going to go to 12. 3 times 12 gives me 36. 12 plus 36 is 48. And I got it. Okay, last problem. The sum of Cooper's, Dante's, and Maria's ages is 31. Dante is twice as old as Cooper. Maria is 1 year older than Dante. How old are all of them? Okay, so we've got Cooper. We have Dante, and we have Maria. Okay, so what do I know here? I know Dante is 2 times Cooper. And Maria is 1 year older than Dante. So Maria is Dante plus 1. Don't know anything about Cooper, so this is going to be my guess. And I know that their total is 31. Okay, so we've got Cooper, our guess. We have Dante, which is 2 times Cooper. And finally, we have Maria, which is Dante plus 1, and we have our total. Okay, they add up to 31. Okay, I'm going to start again with 10. It seems reasonable. So 10, this will be 2 times 10, which is 20. This is going to be 20 plus 1, which is 21. So 10 plus 20 plus 21 is 51. So that's too high. Oh, let's go to 5. Two times 5 is going to give me 10. 10 plus 1 is going to give me 11. So if I have 5 plus 10 plus 11, that gives me 27. This is too low. Okay, but it's closer. 31 is closer to 27 than it is 51, so I think I'll go to 6. 2 times 6 is 12. 12 plus 1 is 13. 6 plus 12 plus 13 gives us 31. And there you have it. Okay, the end for 1.5.